Okay. Thanks, Warren.
Sarah has.
Friday,
Yeah,
10:59.
Sorry about that. Maybe something on there.
You can sit behind you.
So, here's a minute.
Can see Guinness is possible.
Good. Okay. How do I get it?
Yeah, usually you guys are about wow. It was in the past, but it's describing cards. It was no go.
If you're presenting, you want me to do next?
Yeah.
Yeah, that's fine. As long as it's straightforward, like the arrow keys. I can do arrow keys.
Animations.
Okay. And what do I do in this?
Just next again.
Okay. Okay.
So we'll do the instruction.
Okay.
Yeah, I've done this before. Just left, right, left, next to previous, and yeah, wrong one. And I may have to. It normally. Okay, I think you're set, doesn't? Is it? No, I'm not sure what's going on now. Maybe you can get it back.
Should I push the escape button since while we still have it?
Yes. I mean,
I can just do.
yeah, let's not go back to it.
Thank you, everyone. Sorry for the late start. So welcome today to the EDU tutorial on DNS privacy. My name is Sarah Dickinson. I'm very glad to see so many faces here today. So I'll move forward onto the overview of what we'll talk about today. So the tutorial is basically split up into 3 sections. The first section is going to be a background of why are we talking about DNS privacy as an issue and how did this arise? And to kick that off, Daniel Kahn-Gilmore has kindly agreed to give a few slides to set this in the context of the bigger picture of internet privacy. After that, we'll move on to talk about the huge amount of work that's been done over the last 3 or 4 years in this area. A lot of it through the IETF, a lot of it through the Dnsprivacy working group. And then finally, I'll talk about the current status of implementations, deployment, and the tools that are available today. So thank you. So without further ado, I'll hand over.
I'm gonna have to switch.
Yeah.
So I want to talk just a little bit to set the frame for why DNS privacy matters. More generally, it matters sort of, there's a bigger picture. Why does privacy on the internet itself matter? Just to try to motivate it so that we're thinking about this stuff sort of on the same page, you can, looks like it doesn't want to do the full screen thing.
Hold on.
Is it a one-page PDF? That's fine. I can just. There we are. All right. So So the concern here is that there's sort of an issue of possibility of a centralized surveillance state acting as a form of social control. Now, you might be concerned about governmental control. You might be concerned about criminal control, blackmail, a range of other things. But basically, whoever controls the network, if the network is transparent about what's going on, has potentially a lot more power over the citizens. Or the people who use the network. So this is a plan for the Panopticon, which is a prison that's designed so that a warden sitting in the central tower of the prison can effectively see everybody in all of the cells around the outside. And so that allows one or a very small amount of people, the guards in this case, to have control over a very large population. I find that troubling, and I'd like to make sure that the network where the smarts are at the edges doesn't make it so that the center actually has control over the smarts at the edges. So the next. So the DNS, when we think about what goes on in the DNS, we're often thinking about sort of that it's basically like little bits of metadata, like what host names are you looking up? And that's associational host data. So a request comes from you for a particular name. Those names potentially mean things. And I want to just point out that like associational surveillance is actually probably the most sophisticated form of surveillance that we have. If you're thinking about global surveillance, it feels creepy to think of somebody knowing what you're saying, but actually the things that machines can learn at scale are significantly more powerful these days than just content analysis. And so this associational stuff, this is a slide from a leaked slide from the NSA. They're only one of the groups who are doing like intense associational surveillance. But the kinds of associational surveillance they can do is mapping particular people to particular groups. So you can imagine with the DNS, the sorts of mappings that could go on, did you visit Alcoholics Anonymous? That tells somebody something. So whoever controls the network has an opportunity to know, if they're just watching what traffic goes on, what sorts of people have connected to what sorts of groups. So the DNS is part of that. So you can do the next slide. So it's also not just host names, right? The DNS has, we think of it as most commonly, it's just we're going to look up an address from a name, but there's lots of other stuff that can be stored in the DNS. And if you look around what's going on at the IETF, there are a bunch of other opportunities to use the DNS that are not just host names. They're not as widely used, of course, as the address lookups that we're all familiar with. But in fact, there's a bunch of other stuff that's coming down the pike. There's old stuff like MX records, which will actually leak information about what domain you're emailing to. And then there's things like OpenPGP key, where you might actually end up sending the name of whoever you're contacting directly to the DNS. Or not the name, but the individual email account, which is a significantly larger privacy leak. So there's a bunch of other stuff that could go on in the DNS, and people want to use the DNS for that. And so we need to make sure that DNS queries aren't as obviously subject to associational surveillance. And so just to sort of reinforce why I think the social control issue is a thing here. So this is a study that was done, I think this year, at the beginning of this year, where they basically took a bunch of people and they asked them their opinion on some topics that were fairly contentious. And then they asked them their opinion about the sentence, is it like basically, is centralized surveillance okay? And it turns out that this is sort of along the lines of if you're not worried about it, if you got nothing to hide, you've got nothing to worry about, right? There's a lot of people who have that sort of instinctive response. And it turns out the people who say, if you're not, if I've got nothing to hide, I'm not worried about surveillance. Surveillance is justified to keep society safe. The people who say that, when it comes to things where they are in the minority, where they feel like they are more in conflict, they're actually less likely to speak up. So this is actually an ecosystem problem where the fact that we have all of this additional leakage means that people are less likely to dissent and our society is less likely to be able to evolve. So these are different groups of people who have different opinions about the legitimacy of surveillance. And the graph here shows friendly, neutral, and hostile. So if you think you're saying something into a hostile environment and you think surveillance is okay, you're actually less likely to speak up at all. So there's a chilling factor of having the centralized surveillance. So it's not just about, are you individually concerned about being spied on? It's about what can society do how does society change? How does the behavior change as a result of having this? So we want to make protocols that encourage people to feel that they are protected, so that they actually can communicate with people even in an environment where they might otherwise feel like it's a hostile environment. And I want to point out that DNS is one little piece of these leakages, right? So this is a boat here. DNS is leaking in the middle of the boat, but there's leaks coming from the TLS layer, the server name indication in TLS leaks. There's leaks from the traffic size of different kinds of packets that you send, timing patterns. There's probably lots of other leaks that we don't know about. And a lot of times in the IETF, we're working in these little silos. And I've heard in multiple situations, people say, oh, well, we don't have to worry about that leakage because it's just as bad as this other leakage that's happening somewhere else. Well, in a leaky boat scenario, you actually need to fix all the leaks. You can't just say, I'm not going to fix my leak because this other leak over here is leaking also, right? We want the boat to stay afloat. So the motivation here is to try to make sure that we can actually get, I mean, there's a lot of work ahead of us. We actually, these are theoretical concerns, and some of these, like the question marks there, are real question marks. Like these are, there's ongoing academic research about what kind of information can be determined from things like timing patterns. And we don't have all the answers, but we know that if we don't fix the things that we know how to fix, we're not going to get to all of them. So that's just the motivation for why we care about DNS privacy. It's not going to solve all the problems, but it's a step in that direction. So give it back to Sarah for.
Thank you.
Well done.
Okay, thank you very much. So I hope that's given you a flavour for some of the context of what we'll talk about today. So what I'd first like to do is, before we dive right deep into what's been happening in DNS world, is talk a little bit about what's been happening at the IETF level in general in terms of privacy. Now, of course, the Snowden revelations were a big thing, and it got popular awareness about mass surveillance out there. A lot of people sort of tend to think that kind of caught the IETF napping, but what I want to illustrate here is that really isn't true. The IETF was very actively involved in all sorts of privacy work well before that. There were numerous workshops, and quite importantly, in March 2011, work was started on a draft that was to guide protocol developers on how to add privacy considerations into their drafts in a very similar manner as to the way security considerations are quite naturally put in drafts. So the folks behind that started back in 2011, and they were right on the verge of getting it published as an RFC when Edward Snowden revealed his data to the world. So you kind of got a feel for these guys a little bit, getting their thunder stolen there. But what the IETF did is it came back swinging. It very quickly reacted with a very important document, which is RFC 7258. And this declares clearly that pervasive monitoring is an attack. I'll talk about that a little more in a moment. The work at the IETF level has continued, though. There are several other RFCs in this area. There are many drafts in progress. So I just want to illustrate that there is a lot of work going on at the leadership level in the IETF with regards to privacy. I just wanted to pull out just a couple of statements from RFC 2558 in terms of clarifying that the IETF's position on this is that pervasive monitoring is an attack on internet users and organizations. And the declared aim in future protocol developments is to mitigate the effects of monitoring through protocol design. So doing it at the lowest level, not necessarily operationally, but making sure protocol design takes this into account. So to move on to see where this intersected with DNS. So if you think back in time a little bit, first of all, I'd like to time travel you back to 1987. So pick your DeLorean, your TARDIS, your phone booth, time machine of choice, and go back to 1987. So there was a lot of bad hair, a lot of good music, and the DNS was being standardized at that time. And to put it in context, at that time, it was a building block in the internet. And the main goals behind the design of the infrastructure of the DNS were availability, redundancy, and also speed. So those are the things that foremost in the people who are developing the protocol. In privacy terms, the DNS is described as an enabler. It's a system that you use to get to other services. So You want to get to a web page, you go via the DNS. You want to email somebody, you go via the DNS. So that's where it sits. Now, it was still true of the standards in 2003 that the standard transports for DNS were UDP and TCP. And even last year, over 99% of the traffic going up to the route went over UDP, and importantly, this is clear text. So all your DNS queries are going clear text over the internet. So this meant this was fair game for somebody like the NSA with their more cowbell tool. It really wasn't a tricky job for them to monitor DNS traffic because of the way it moves over the internet. There was a very small amount of TCP around, but it was really only used for corner cases. There was also at this time, and for much of the sort of 25-year time period here that I'm spanning, a perception that the DNS is public, right? I mean, anybody can query these records, anybody can get to them. They don't contain personal or sensitive information, so we really don't need to worry about encrypting this or protecting it in any way. It's the DNS. And that was out there for a long time. So you have to bear those things in mind when you look at the design of the DNS and be a bit forgiving. So this is the basics of how the DNS works. You're on some client machine. You want to resolve a name. You send the full name up to the recursive server that you're using. Now, what the DNS does is if it doesn't have that name in cache, it sends the entire name up to a root server to get a delegation for, in this case, .org. Then it sends the entire query to the .org authoritative server, and so on down the chain until it gets to the one that can provide the answer. Now, with hindsight, and your privacy hat on, you look at this and go, oh, that infamous bad idea fairy was around when they thought of this, right? Because those two queries are leaking information. Who at the root needs to know the full question that the client asked? They don't need to in order to resolve it. But this was how the DNS was designed originally. Something else interesting happened just about this time frame as well, 2013. And that was the standardization of a mechanism called EDNS 0. Now, this was a really nice idea and something the DNS really needed. It enabled embedding information inside a DNS query that was flexible. It could contain capability options. It could allow clients and services to negotiate things like path MTUs. It was great. The DNS needed it. As a side effect, though, what this did is it enabled certain organizations to take advantage of this to embed user data directly inside those DNS queries. But the way this was positioned at the time was that it was all for the greater good. So, for example, one of the mechanisms here was ISPs saying, we want to offer you filtering, parental filtering, protect your kids, or even more sophisticated filtering. And we can do this at our recursors if we know who's making those queries. Similarly, CDNs argued that if we know where you are located geographically, we can divert you to your nearest server and you will get great streaming and your cat videos will never buffer again. Isn't that wonderful? Aren't we doing you a great customer service? So this all sounds great and people sign up for it. What they don't realize is what this means in practice. So the way the user identification worked is that your ISP would give you a router, and very often that router would add in to the DNS queries as they came out of your home network information about you. That might be a MAC address. In some cases, it was observed that it was usernames or user IDs, something unique. And that meant they could do their filtering at the recursive, but it also meant that anybody who was passively monitoring that link could immediately correlate all those queries with the activities of individuals behind that router. So that could allow not only for identification of individuals, but tracking of individuals as well. In a very similar manner, the way the client subnet worked was that there was an implementation in the recursive that said, well, we know who sent us this query, pick up their subnet and send that up to the authoritative so it can figure out their geolocation. But again, this is leaking information to anybody passively monitoring that link up to the authoritative, again creating correlations within the data with the activity of users or groups of users. So what this really means is, even when you're sat at home, you're behind a NAT and you think you've got anonymity, you don't necessarily. And even though you're behind a recursor and you think you've got anonymity, you don't necessarily. And both of these were done originally with non-standard options. Some of them are now coming through the standards process, but there really wasn't anything to stop organizations doing this because people were happy to sign up to the services, which sounded great. And as DKG alluded to, the kind of careers you do reveal quite a lot about you on both of these legs. So I don't know about me, but I'm at home. Before I came here, I was looking up what conference I was going to, what hotel I was staying at, what flights I was taking. So this revealed an awful lot about me, including how distracted I can get when I'm trying to put a big slide deck together and what sites I go wandering off to. But this is all information they can correlate back to me. So I hope at this point I've got your spidey senses tingling with the idea that there's all sorts of stuff going on in the DNS that you don't necessarily know about as an end user, even if you're quite technically aware. To take this another step further, so we've looked at the kind of leakages you get on DNS queries that are in flight. This is thinking about them at rest. So you have a recursive resolve that you're using. So you have to start considering who are the people who have authorized access to the data there, to what's been logged about all the queries coming in. What third parties are they sharing it with? What legal commitments do they have to gather data on users? Equally, what are the risks of unauthorized access to that data? How solid is the security? Could there be breaches? And also, those concerns will change as you move around different recursors. So as you're at home, as you're at work, as you're in a coffee shop, as you're in a hotel. And these are things that people aren't necessarily aware of. Equally, those concerns extend up to the authoritatives, because as you can see, information can make it up to that level about the activity of individuals. So those are the sort of salient points about DNS data leakage. There are an awful lot of complications. I want to just touch on one here, which is something which particularly lately has become more active, and that's DNS filtering. So this is happening at country level and at ISP level, organizational level, and it's activities whereby people running recursors will have a blacklist of sites they don't want people to get to, and they will actually tell DNS lies in order to block access to those sites. Again, this is trying to be done for the greater good, keep you away from websites infected with malware, etc. Although accidentally some other sites get blocked every now and again that you might want to get to, like Google. This has happened by accident. But the thing to think about is, if you are using a recursor that engages in this kind of behavior with these blacklists, how likely do you think they are to track users who trigger their blocking due to trying to access one of these blacklisted sites, even if you do it by accident? So this table tries to summarize the hotspots in terms of DNS data leakage, in terms of what's happening on the wire and at rest. And I'll come back to this later and show you where we are in terms of tackling this. So that's a picture in classic DNS as you know it. I want to spend just a little bit of time talking about something which is called DNS service discovery. So this happens within local networks, and the mechanisms used can be regular DNS constrained to that local network, or it can be multicast DNS. What this does is essentially the procedure whereby a device can advertise some services that it is willing to make public, and other devices can discover those services and use them. And this is really cool because it means you can do stuff like file sharing, photo sharing, all sorts of stuff directly over the network. And that's nice. And most of the services that utilize this are secure. The problem comes in advertising those services. Now I can see a whole bunch of Macs here, and I know that if